Hello everyone, in this video we will learn all about derivatives of a function. Let's have derivative as the slope of the tangent line. Now, a tangent line is a line that touches a curve at a point, matching the curve's slope there. Now, given this figure, we have here a curve P. This red line here is the tangent line that touches the curve at point P. Okay, given this, AB is a tangent line that touches circle O at point T. Now, given this, the red line here is the tangent line. It touches the curve at one point, while this green line here is the second line. It touches the curve at 2 points. Now, tangent lines to circle. Now, looking at this one, at points positive and negative 1, 0, the tangent lines are vertical, while at points 0, positive and negative 1, the tangent lines are horizontal. Now, with this one, at points in the first and third quadrants, the tangent lines are falling lines, while at the points in the second and fourth quadrants, the tangent lines are rising lines. Now, let's compare and contrast a tangent line versus a second line. So again, a tangent line touches a curve at one point, while a second line touches a curve at 2 points. Now, let's define tangent formally. Now, given this curve, which is y is equal to f of x, we have here line PQ, which is actually a second line. Question: what happened as Q approaches to P? So, with this Q moving to P, you try to look at what happened to the second line. So, given this one, so again, as Q approaches P, the second line PQ eventually became a tangent line. So again, a second line passing through P is any line connecting P to another point Q, while a tangent line passing through P is the limiting position of all second lines PQ as RQ approaches P. So take note, derivative is used in identifying how changes are made. So again, when you say slope of the tangent line, it is just like saying from the second line, eventually it became a tangent line. It's the limiting position. Now, there are curves that do not have tangent lines. Number one, the case when the function is not continuous at a certain point. So, if it is not continuous, eventually you cannot get its derivative or the slope of the tangent line. Another case, when the function has a sharp corner or cusp at P. So, for example, given this, so there is a corner at P. So the same thing with this one. So if your graph is like this, it has no slope of the tangent line, or you cannot get its differentiation or derivative. Now, again, going back, we have here second PQ, and we have here a tangent line at P. So if the coordinates of Q here is xy, and the coordinate of P here is x1 and y1. So, letting Q approach P is the same thing as saying letting x approach x sub 1. So, take note when you get the slope of PQ, it's just like getting the difference in y over the difference in x. So, slope of PQ is y minus y1 over x minus x sub 1. So take note to get the slope of the tangent line, it is the same as saying finding the limit of the slope of PQ as x approaches x sub 1. Or it's the same thing as saying the limit of f of x minus f of x sub 1 over x minus x sub 1 as x approaches x sub 1. So how come it's like this? So actually these two are exactly the same. So if we have here y, so take note, y is basically the function of x. So that's why you have here f of x. While y sub 1 is eventually the function of x sub 1. So since the tangent line passes through the point x sub 1, y sub 1, then its equation is y minus y sub 1 is equal to m, which is the slope, times x minus x sub 1, which is the point slope form. So again, to find the equation of the tangent line, the first thing to do is get the slope of the tangent line using this formula, or you can make use of this. They would end up with the same value. Then number 2, substitute in the point slope form. So let's have an example. Find the equation of the tangent line to y equals x squared at x equals 2. Now graphing this, y equals x squared, this is our graph. Now this is a graph. It's a parabolic that opens upward at x equals 2. At x equals 2, that's where the point of tangency is. So this one here, this is our tangent line. So again, if our x is 2, our y here is 4. So how was it obtained? So simply substitute 2 to the power of 2. Eventually, you will get 4. Now, getting the slope of the tangent line. So having this, so let's substitute. Our f of x is x squared. Now, if our x is 2, our f of 2 is 4, then over x minus 2 as x approaches 2. So take note, we cannot substitute 2 right away. So with that, we will factor. So factoring this, we can cancel. So we will end up with the limit of x plus 2 as x approaches 2. Substituting x by 2, so we will end up with 4. So the slope here of this tangent line is actually 4. And to get its equation, then substituting here, so our y is 4, our slope is also 4, and our x is 2. So simplifying further, we will end up with y equals 4x minus 4. Okay, another example. Find the slope-intercept form of the tangent line to f of x is equal to the square root of x at x equals 4. Now, sketching square root of x, so it would look like this one. This is a graph of square root of x, and at x equals 4, so we will get this. This is where the point of tangency is. So if our x is 4, our y is 2. So how is the y obtained? So that's simply square root of 4, which is 2. So finding the slope of the tangent line, so all we have to do is substitute f of x square root of x. Our f of 4, it's 2 over x minus 4 as x approaches 4. So with this one, let's rationalize by multiplying its conjugates. So we will end up with this square root of x times square root of x, that's x. Negative 2 times 2 will get 4. So with this one, we can cancel x minus 4, and we will end up with the limit of 1 over square root of x plus 2 as x approaches 4. So with this, substituting, we will end up with m as 1/4. So substituting in the point slope form, so we will end up with y equals x over 4 plus 1. So take note of that. Another, find the slope-intercept form of the tangent line to 3x squared minus 12x plus 1 at the point 0, 1. So take note at this point, a point is already given. So getting the slope of the tangent line, so we have here 3x squared minus 12x plus 1. Again, our y here is 1, so that's a minus 1 over x minus our x is 0 as our x approaches 0. So simplifying, we'll end up with this. So factor out x, we'll end up with 3x minus 12. So with this, we can cancel x. So we'll have 3x minus 12 as x approaches 0. Substituting, we will end up with slope as negative 12. So to get its equation, so substitute. So simplify, we will end up with y equals negative 12x plus 1. Now, the definition of derivatives. Now, take note, given this one, to get the slope, it's change in y over change in x. And take note, we can sketch a right triangle here. So, this one, to get the distance of this is actually x minus x sub 1, or this change in x. And this one here is y minus y sub 1, or that's basically change in y. So take note, when you see tangent, it's opposite over adjacent. So if this is angle theta here, opposite to that is change in y, so y minus y1, over adjacent, which is change in x. Or again, the slope of the tangent line is basically the limit of f of x minus f of x sub 1 over x minus x sub 1 as x approaches x sub 1. So now, given this is change in x, this is also change in y, this is our x. So if this is x, this is change in x. So to get the coordinate here, it's change of x plus x. And this one, this is f of x. And this one here is f of x plus change of x. So with this, when you say slope of the tangent line, it's the same thing as the derivative of x. So our f of x here, we have here, our function is f of x plus change of x. Our f of x sub 1, so we have here f of x over x plus change of x minus x as change of x approaches 0. So take note, we obtain this by simply substituting the original formula for finding the slope of the tangent line. So this one. So again, x minus x, you can cancel. So we will end up with this. So this one is actually the derivative of a function at x. So take note, we have here the derivative of x is the limit of f of x plus change of x minus f of x over change of x as change of x approaches 0. So take note, there are different notations of derivatives. It could be f prime of x, it could be y prime, it could be dy over dx, it could be d of x of y, or it could be d of dx of y. So take note, all of this would mean the same thing. It means derivatives. So take note of that. It's the notation of derivatives. So again, so in getting the derivative of a function, we can make use of this first formula, or we can make use of the second formula. The same thing, we will end up with the same answer. So let's have an example. Find the derivative of 3x minus 1. Now, making use of the first equation, so with this, we have here 3. Our x will be replaced by x plus delta x minus 1. Our f of x is delta x, 3x minus 1 over delta x. So substituting here, so we can cancel. So we're left with 3 delta x. So with this, we can cancel. So we end up with the limit of 3 as delta x approaches 0. So take note, it's a constant. So our limit here is 3. Now, given this, if our x is 1, so substitute 3 times 1 minus 1 will end up with our y as 2. So substituting, so f of x here, that would mean 3x minus 1. Then our y is 2. over x minus 1 as x approaches 1. So factor out 3 here. So we can cancel x minus 1. So we will end up with the limit of 3 as x approaches 1. It's still 3. So again, whatever method you will use will end up with the same answer. Okay, another. Find the derivative of 3x squared minus 5 at y prime of negative 2. So again, making use of the delta method, we will have this one. So all you have to do is substitute. So with this, we can cancel 3x squared and negative 3x squared. So we end up with 6x delta x plus 3 delta x squared over delta x. So take note, dividing the entire equation by delta x, we end up with 6x plus 3 delta x, and substituting x delta x by 0, so we end up with y prime 6x. So since our x here is negative 2, so let's substitute, we end up with negative 12. Okay, another. Now again, if our x here is negative 2, our y here is 7. So how is 7 obtained? Simply substitute here. So with that, making use of the derivative as slope of a tangent line, so we will get this. Our f of x, 3x squared minus 5. Our y sub 1 is 7. As x approaches negative 2. So again, we cannot simply substitute negative 2, otherwise it will become undefined. So with this, factor out 3. So factor this further. So we can cancel x plus 2. So that would be the limit of 3x minus 2 as x approaches negative 2. So substituting, still we end up with negative 12. So take note of that. Either method, we will end up with the same answer. The derivative of a function is also interpreted as the instantaneous rate of change. It is an important quantity in physics, the instantaneous velocity of a moving particle. Now, suppose that an object or a particle starts from point A and moves along a straight line towards B, and it is positioned along the line AB at time t is s. The motion of the particle is described by the position function s is equal to s of t, where t is greater than or equal to 0. And since the particle moves along a line, it is said to be in rectilinear motion. Now, suppose that a particle moves along a line with position function s of t as 2t squared plus 3t plus 1, where s is in meters and t is in seconds. Question: what is the initial position? So in here, the initial position, it means the time is 0. So with that, our time is 0, so substitute. Our initial position is located 1 meter from the starting point. Okay, another. Where is it located after 2 seconds? So where is the particle after 2 seconds? So our time here, simply substitute it by 2. So we will end up with 15 meters. Okay, another. At what time is the particle at position s is equal to 6? So again, the position is 6 meters from the starting point. So replace s of t as 6. So simplifying this, we will get this one. So factoring this, so we will end up with t1 as negative 5 halves and t2 as 1 second. So go for 1 second. So with this, the initial position is located at 1 meter from the starting point. After 1 second, it is already 6 meters from the starting point. And after 2 seconds, the particle is already 15 meters from the starting point. So take note of that. Now, the same given. So with this, to get the average velocity, so that would be displacement over time elapsed. So what's the velocity from 1 to 2 seconds? So meaning, what is the speed? So with that, s of 2, that would be 15 minus 6 over 2 minus 1. So with this, the velocity from 1 to 2 seconds would be 9 meters per second. So take note of that. Now, if we will find the average velocity from 1 to 1.5, 1 to 1.1, and 1 until 1.001, we will get this corresponding average velocity. So again, this is displacement over time elapsed. Now, another one, from 0.5 to 1, so 0.9 to 1 or 0.999 until 1, we will get this average velocity. So take note with this, the limit of the velocity or average velocity as time approaches 1, it's basically s of t minus s of 1 over t minus 1. So take note, this is the formula for the derivative of instantaneous velocity. So take note of this. Now let's have this. A ball is shot straight up from a building. Okay. Then its height in meters from the ground at any time is given by this one. So number 1, find the height of the building. So from the starting point, so you did not release the ball yet, so the time is 0. So with that, substitute t as 0. So with that, the building is 40 meters in height. Okay, another. What is the time the ball will hit the ground? So take note, the ball started 40 meters above the ground. So with that, its height should become negative 40 so that the ball is already on the ground. So with that, let's substitute and simplify. So we will have this, or we can get this one. So making use of quadratic formula to find t, we'll get this. So our time is 7 plus and minus square root of 13 over 2, or that is approximately 8.8 seconds. So by 8.8 seconds, the ball is already on the ground. Okay, another. Okay, now exactly the same given, but this time, find the instantaneous velocity at any time t of 0. So take note, this is the formula for instantaneous velocity. Substituting this, the limit as t approaches t of 0. So our s of t, so that's the original function, minus our s of 1 would be t of 0. So substitute t by t of 0 over t minus t of 0. So with this, simplifying, we will get this one. So with this, we will factor out 35. So we'll have t minus t of 0, factor out negative 5, so we'll have t squared minus t of 0 squared. So take note, this is difference of 2 squares, so we can still factor that. So with this, dividing the entire equation by t minus t of 0, so we will end up with 35 minus 5, t plus t of 0 as t approaches t of 0. So with this, substitute t by t of 0, so we will have 35 minus 5, t of 0 plus t of 0, that would become 2. So 2t of 0 times 5. So we will have 35 minus 10 t of 0. So to get the average velocity at any time, we will make use of this. So with that, what is the instantaneous velocity if the time is 1 second? So substitute, so that would be 35 minus 10 times 1. So therefore, at 1 second, the average velocity of the ball is 25 meters per second. Now, what about if the time is 2 seconds? So what is the instantaneous velocity of the ball at 2 seconds? So again, substitute it here. So that would become 35 minus 10 times 2. So 35 minus 20. So that would become 15 meters per second. So again, to get the instantaneous velocity, we can derive it like this and substitute. So take note of that. Okay, differentiability and continuity. Now, differentiability implies continuity. So take note, the operation in finding the derivative of a function, it is called differentiation, or finding the derivatives. Now, if a function has a derivative for a particular value of x, the function is said to be differentiable at the value of x. So, for example, are the following functions differentiable? Number 1. The answer is yes, at any value, because this is actually continuous. Now, what about this parabolic line? It is still differentiable at any value of x. Now, what about number 3? This is a graph of the square root of x minus 5. So, this is not differentiable at x equals 0. So, let's have more example of this. Now, given this, are the following functions differentiable? So this is a continuous graph and it's a curve-like. So the answer here is yes at any value of x. Now what about this one? This is a jump. It has a jump discontinuity at x equals 1. So with this is not differentiable at x equals 1. Now what about this one? This is infinite at x equals 1. So with this is not differentiable at x equals 1. So take note. Once it is not continuous, it is not differentiable. So take note of that. So let's have another example. Now this is the graph of an absolute function. It is continuous, but let's try to check if it is differentiable or not at any point of x. Now when you say absolute value function, our y here is x. If our x is greater than 0, so x greater than 0, that would be x. Then if our x is 0, our y is also 0. Now, if your x is negative 0, so that would mean negative values of x. So if we will get the derivative of this one, take note, the derivative of x, that's 1. But derivative of 0 is, it does not exist. And derivative of negative x is negative 1. So meaning at x is equal to 0, the derivative does not exist. Or the tangent line does not exist. So an absolute function is continuous, but it is not differentiable at x equals 0. Because aside from that, when you draw your tangent line at this point, it is actually a horizontal line in which it is slope is equivalent to 0. So take note of that. A graph could be continuous, but it is not differentiable. So take note also at x equals to 0, there is a sharp corner at this point. Okay, another. Now, this is a graph of y equals square root of x. So take note. If x is greater than 0, so you simply get the square root of x. Now, if x is exactly 0, so that would mean square root of 0. But when you see x is lesser than 0, it does not exist. Because again, never take the square root of a negative radicand. So with this, the graph of square root of x is continuous starting from 0 until positive infinity, but it is not differentiable at x is equal to 0. So take note of that. Okay, you might say that getting the derivative of a function is quite a long process, but actually there is a shortcut to that. So let's have this rules of differentiation. So let's try to observe how the derivative of a function is obtained. Now, if we're given y is equal to x squared, so the derivative of this is 2x. Another, if you're given y is equal to x to the power of 3, the derivative to this is 3x squared. Another, if you're given y is equal to x to the power of 4, the derivative to this is 4x cubed. Now, if you're given y is equal to x to the power of n, to get its derivative, it's simply n, x, and minus 1. So when you see getting the derivative of a function, it is simply multiplying the exponent by the coefficient, then minus the exponent by 1. Again, it's multiply, then minus 1. Okay, let's have another example. If we're given 5x cubed, so that would be 5 times 3, that would be 15, minus 1 is x squared. Another, if you're given 8x5, so that would mean 40x4. Now, what if you're given 7x? So when you see 7x, the exponent here is 1. So with that, the derivative to this is 7. Because again, if this is 1, minus 1 will become 0, and that will become 1. So another, if you're given negative 3x, derivative to this would be negative 3. Now, what about if you're given a constant? Like, what is the derivative of constant 4? So with this, our answer is 0. So how come it's like this? Now, remember, 4 is just the same as 4x to the power of 0. So 0 times 4, it is already 0. Then 0 minus 1, that would become negative 1. So again, derivative of a constant is always 0. So take note of that. Basic rule of getting the derivative, multiply, then minus 1. Okay, let's have this one. Basic rules of differentiation, that's the constant rule. So again, when you get the derivative of a function, it's always of a constant, it's always 0. Another, it's a power rule. So when you say x squared, multiply the exponent, then minus 1, that's 2x. The constant multiple rule, so that would be 4x cubed, derivative to that would be 12x squared. And we have here the sum rule. So 5x cubed plus 3x squared minus 2x. So we simply get the derivative of each term. So that would mean 15x squared. This is 6x, and derivative of negative 2x, that's minus 2. So take note of that. Okay, another. This is the product rule. So if you're given f of x and g of x, and they are both differentiable, then to get the product rule would mean copy the first, multiply with the derivative of the second, plus copy the second function, multiply with the derivative of the first. So how is it done? For example, if you're given, find the derivative of 4x minus 3 times 2x plus 5. So again, copy the first, then derivative of the second, derivative of 2x plus 5 is 2, then plus, copy the second, so that's 2x plus 5, multiply with the derivative of the first. Derivative of 4x minus 3 is 4. So with this, you simply distribute. So this would become 8x minus 6 plus 8x plus 20. Combining like terms, so derivative of this is 16x plus 14. Now, there is another method aside from product rule. You can make use of bifoil. So bifoil method, multiply this using FOIL. We will have 8x squared plus 20x minus 16 minus 6x minus 15, or we can get this one. So with this, we will get the derivative of this product. So that would mean this is 16x, then plus 14, then minus 0. So take note, we have exactly the same answer, whether we will use the product rule or if we will use the FOIL method. Okay, another. Okay, now for quotient rule, if you're given f of x and g of x, and they are both differentiable with g of x not equal to 0, to get its derivative, copy the denominator, multiply with derivative of numerator, minus copy the numerator, multiply with derivative of the denominator, over copy the denominator raised to the power of 2. So for example, find the derivative of x squared plus 3 over 5x plus 4. So again, copy the denominator, that's 5x plus 4. Derivative of numerator, that's 2x, minus copy the numerator. Derivative of denominator is 5 over 5x plus 4 to the power of 2. Now distribute 2 to the terms inside. We will have this one. So combine like terms, so that would, we will end up with 5x squared plus 8x. So this would become minus 15 over 5x plus 4 to the power of 2. So take note, this is the quotient rule. Okay, another. Okay, chain rule. So when to use the chain rule. So if you're given f of x and g of x, and they're both differentiable functions, so therefore f of g of x is equal to the derivative of f times g of x times the derivative of g of x. So how is it done? So for example, if you're given f of x is equal to 4x plus 3 to the power of 2. So to get its derivative, so multiply 2. So that would become 2. 4x plus 3 minus, so 2 minus 1, so we'll have 1 times derivative of the base. So derivative of the base, derivative of 4x plus 3 is 4. So simplifying further, we will have 32x plus 24. Okay, another example. If you're given y is equal to the square root of 5x minus 2. So how to get its derivative? So again, rewriting this, we will have 5x minus 2 to the power of 1/2. So to get its derivative, so that would become 1/2 times 5x minus 2 times to the power of 1/2 minus 1, that would become negative 1/2 times derivative of the base, derivative of 5x minus 2, so that would be 5. So simplifying further, we will have here 5x minus 2 to the power of negative 1/2 over 2. Or we can have here 5 over 2 and the square root of 5x minus 2. So that's how are you going to get the derivative, making use of chain rule. Okay, let's have this example wherein the product and the chain rules are combined. So find the derivative of y is equal to 3x minus 2 times 5x plus 4 to the power of 2. So again, getting the derivative of this. So copy the first, so that's 3x minus 2. Multiply the derivative of the second, which is 5x plus 4 squared, plus copy the second, multiply with the derivative of the first. So again with this one, copy, so 3x minus 2, derivative of 5x plus 4 squared, so that would be 2, 5x plus 4, so 2 minus 1, that would become 1, and derivative of the base, that would be 5. So again, this one, 5x plus 4 squared, derivative of 3x minus 2, that would be 3. So at this point, we can combine 2 times 5, that would become 10. And this one, we will have 3. So making use of FOIL here, we will have 15x squared plus 12x minus 10x minus 8. So this is 3. Square the first, that's 25x squared. 5 times 4, that's 20 times 2, that would be 40x. Then 4 squared, that would be 16. So at this point, multiplying 10 to the terms inside, that would be 150x squared. So 12x minus 10, that's 2x times 2, that's 20x. So 10 times negative 8 is negative 80. 3 times 25, 75x squared. That would be 120x, and 3 times 16, that's 48. Combining like terms, the final derivative of this given is 225x squared plus 140x minus 32.